Right, let's look at some adding fractions, particularly algebraic fractions, where we have, x's and y's, etc., above and below the line. So the method for adding fractions is all about the lowest common denominator. Anytime you're trying to add fractions or subtract fractions, you always want to be trying to identify, first of all, what's the lowest common denominator. So let's just take a quick flashback to primary school, back to elementary school, when we first learned to add fractions. So if I wanted to add 2/3 plus 3/4, how would I do that? I get the lowest common denominator. In this case, the lowest common denominator would be 12, because 12 is the smallest number that both 3 and 4 divide into. So then I think, all right, with this denominator 3, I multiplied 3 by what to get 12? So 3 goes into 12 4 times. So I multiplied 3 by 4 to get 12. So whatever I do to the denominator, I have to do the same to the numerator. So if I multiply 3 by 4, well then the 2 must also get multiplied by 4. And something similar here. The 4 into 12 goes 3 times. So this 4 got multiplied by 3. So therefore the top 3 must also get multiplied by 3. So that will be 8 plus 9 over 12, which will be 17 over 12. So that's fairly straightforward. You learned how to do that a long time ago. So the good news is the method doesn't change. Just because we're dealing with x's and y's instead of 3's and 4's, the method of adding fractions is the exact same. It's all about the lowest common denominator. So let's have a look at a question here. The question that I shall do for you guys is I'm going to start with this part 4 here. 5 over x plus 6x over x plus 2. So I want to simplify and add those fractions. 5 over x plus 6x over x plus 2. So in this particular case, what is my lowest common denominator? Well, my lowest common denominator in this example is simply going to be x times x plus 2, because both x and x plus 2 will divide into that expression here. Remember, the lowest common denominator is the smallest expression that both the denominators here will divide into. So I figured out that my lowest common denominator is going to be x times x plus 2. So then how do we go from here? Well, we say x divides into x, leaving x plus 2. So the 5 therefore must get multiplied by x plus 2, plus the 6x, well, x plus 2 divides in leaving x, so the 6x is going to get multiplied by x. So we'll just continue then by multiplying out here and expanding. So 5x plus 10 plus 6x times x is 6x squared. And on the bottom, it doesn't make a difference more often than not if you multiply it out or not, but in this case I'm going to multiply it out because it's straightforward enough, over x squared plus 2x. And if you want to change the order on this just to have the highest power first, you can call it 6x squared plus 5x plus 10 over x squared plus 2x. So that's the basic idea. Let's have a look at another example here. So let's say I've got 5 over x minus 2 over 3 plus x over x plus 3. So what's my lowest common denominator in this case? It's going to be x times 3 times x plus 3. That's my lowest common denominator. So equals x times 3 times x plus 3. So x divides into the denominator, leaving 3 and x plus 3. So that means the 5 is going to get multiplied by 3 and by x plus 3 minus the 2. What's the 2 going to get multiplied by? Well, 3 divides in, leaving the x and the x plus 3. So 2 gets multiplied by x and by x plus 3, plus the x plus 3 divides in, leaving the x and the 3. So this x here gets multiplied by x and by 3. And from here on out, it's just a case of multiplying it out and tidying it up and so on. I'm going to take my time with the multiplication, take 2 steps. So 5 times 3 is 15, still to be multiplied by x plus 3. 2 times x is 2x, still to be multiplied by x plus 3. And x by x is x squared, still to be multiplied by 3. All over our lowest common denominator of x times 3 times x plus 3. Notice how I haven't bothered multiplying out the denominator this time. I'm just going to multiply out the numerator. It usually doesn't matter. Sometimes, depending on the question, you will know which is the appropriate root. So we got 15x plus 45 minus 2x squared minus 6x plus 3x squared, all over our lowest common denominator of x times 3 times x plus 3. So let's just take this to the next page and keep tidying up. So we have minus 2x squared plus 3x squared, that's simply x squared, 15x minus 6x plus 9x plus 45, all over my denominator of x times 3 times x plus 3. Now the thing to look out for here would be, on the top of the line, this is technically a quadratic trinomial, but this time it's not factorizable. But if you have something like this, it's worth checking, can you factorize it, because one of the factors above might cancel with one of the factors below. So it's worth checking out. In this particular example, that is not the case, however. So let's have a look at a slightly more difficult example. So the example I'm going to run through with you now, guys, is this part 8 here. Okay. And before I start into this example, I just want to give you a bit of background. So what makes this example a little bit more difficult is we just have to be careful not to overcomplicate the denominator. So let's go back to the basics again. Let's say I wanted to add a half plus 3/4. We know that the lowest common denominator in this case should be 4, because 4 is the smallest number that both 2 and 4 will divide into. So I would say 2 goes into 4 twice, so the 1 gets multiplied by the 2, plus 4 goes into 4 once, so the 3 gets multiplied by 1. 2 plus 3, we've got 5 over 4 is our answer. Now what happens in some cases is sometimes if we have a half plus 3/4, people might say the denominator, the lowest common denominator, is 8, because 2 times 4 is 8. Now while 8 is a denominator, it's not the lowest common denominator. So 8 is a common denominator, but not the lowest common denominator. So we would like to get the lowest common denominator. Now what happens if we don't use the lowest one, if we use 8? The method is still the same. 2 goes into 8 4 times, so 1 gets multiplied by 4, plus what's the 3 going to multiply by? Well, 4 goes into 8 twice. So you're going to have 4 plus 3 times 2, so 4 plus 6, you're going to have 10 over 8 is the answer we get here. Now you can see 10 over 8 is really the same thing as 5 over 4. It can be simplified as 5 over 4. So whilst we didn't pick the lowest common denominator in this particular case, we did get an answer that could be simplified to the same answer as we had earlier. So even if you don't pick the lowest common denominator, you will get an answer that is technically correct, but it might not be the simplest form of the answer. Now, when you're dealing with numbers, this may not be a big deal, but when you're dealing with algebraic terms, sometimes it can be very messy if you don't use the simplest version of the denominators. So let's have a look at this example here. So we've got x over y squared plus xy minus y over x squared plus xy. So what's my lowest common denominator in this case? So what we need to do is see if we can factorize the denominators first. So looking at our example here, we can definitely factorize the denominator. So I'm going to rewrite the question and say this is x over y times y plus x minus y over x times x plus y. So sometimes if the denominators of the individual fractions can be factorized, it's a good idea to do that, because this will help us get the simplest version of the lowest common denominator. So I can see in this particular example, my lowest common denominator will be y multiplied by x plus y. It's important for us to remember that y plus x and x plus y are really the same thing. So both denominators contain an x plus y, which is why we want to factorize them to spot that. So continuing on here, our lowest common denominator therefore is y times x plus y. So then the first fraction here, y by y plus x divides in, leaving simply this x. So we've got x times x minus y times, well, this denominator will divide in, leaving y, so y gets multiplied by y. So that leaves us with x squared minus y squared over y by x plus y. Now, we are still not finished, however, right? What we have to do is simplify it. So what we're going to do is have a look, can this be simplified? And if you look at the top definitely can be simplified by the difference of two squares. we're going to take this onto the next page and simplify it a little bit further. So x squared minus y squared can be simplified as x minus y times x plus y using our difference two squares over y times x plus y. And as you can see, we have an x plus y multiplied into the top and an x plus y multiplied into the bottom. So they're going to cancel each other out, leaving us with x minus y over y times x. Let's call that xy. And that is the simplest version of our answer. Whilst this version here was not technically incorrect, it was definitely an overcomplicated version. We have simplified it right here. Now, if we look back at the question, remember, we factorized the denominators just to keep it a little bit simpler. Imagine how complicated it could have been if we had said that our lowest common denominator here was y squared plus xy over x squared plus xy. That would have led to a much more difficult situation. While technically not incorrect, it would have been much more overcomplicated. What we want to do, as you've already seen, is if you can factorize the denominators, go ahead and do that, because that will definitely simplify the situation for you. So that is how to add algebraic fractions. The best thing for you guys to do now is go ahead and practice some of these questions, and you can get your solutions on the website. And please subscribe for more detailed and worked out solutions.